Respected delegates, respected paper presenters, ladies and gentlemen, one and all. This is Anupani Bajracharya. I am engaged as a microbiology lecturer and head of Department of Microbiology in Balkumari College, Narangad, Chittoor. So first of all, I would like to express my sincere gratitude to the organizing team for giving me this platform to present my research work entitled Isolation and Characterizations of the Plant Growth Promoting Rhizobacteria from Rhizospheric Soil of Maize Plant of Bharatpur. Let's get through the introduction first. The major issues in today's world is the growing global population. The population is growing day by day. The population is growing day by day in India as well as in Nepal. The huge population requires more amount of the food. And as we know that food is the fundamental needs of the human life. The food is essential for the human health as well as the society progress. Now, for the large amount of the population, how to manage the food, that is the most challenging issue nowadays. So to get more and more food, farmers are using different sort of chemical fertilizers, chemical pesticides and chemical insecticides in the field. Next please. So these chemicals which are using on the land, like the agrochemicals runoff from the land to the water bodies, may contaminating the water bodies and causing the various badly affect the life on earth through bioaccumulation and biomagnification through the food chain. These pesticides also killing the beneficial natural insects, natural flora of the soil and decreasing the soil fertility. So if we use the chemical fertilizer, we have the several negative impacts such as environmental pollution, soil degradation, there is an emission of the greenhouse gas also, and there is a negative impact of the health of the human as well as animals and plants, and it is costly for the farmers also. You can see in the picture that is the algal bloom, eutrophication, that is due to the excessive use of the chemical fertilizers. Now, what is the solution? What is the sustainable solution for this increasing global population? The solution will be the PGPR, that is Plant Growth Promoting Rhizobacteria. Now, these rhizobacteria are the bacteria which are around the roots of the plants, which helps the plants to grow effectively or efficiently, and they help the growth of the plant by variety of the mechanisms like phosphate solubilization, nitrogen fixation, CDL4 production of ACCD aminase, biofilm formation. So there are different sort of the merits points which can contribute for the plant growth and development. So we can use PGPR, the bacteria, as the biofertilizer. Now we have to avoid the chemical fertilizer and we have to go forward for the biofertilizer, because biofertilizer is the only solution for now to have the safe food for the overgrowth population of the globe. Next slide. My objective is to isolate and identify the plant growth promoting rhizobacteria from the rhizospheric soil of the Bharatpur, Chittoor. And my specific objective includes to isolate the bacteria, to screen the isolates, and to determine the physical and chemical bioproperties of the selected isolates. And I also perform the antimicrobial susceptibility test of the bacteria. So in methodology, what I have done first is I have collected soil sample from 4 different regions of the Bharatpur. And these soil samples were processed for the isolation in 2 media, that is YMA and PVK, that is East Manipur agar and Prosbakska agar. So different screening tests, hydrolyzing enzyme tests, morphological characterization, biochemical tests and physiological characterization has been done. So these are the sampling sites: Krishnapur, Rampur, Bassetti, Gondran, from where I have collected the soil sample. So first in screening test, four tests I have performed: phosphate utilization, nitrogen fixation, indole acetic acid test, and ammonia production test. And all altogether I have isolated 79 bacteria, and among these 79 bacteria, because of the time constraint, I have only selected the 8 bacteria from there, and out of 8 bacteria, none of the bacteria can fix the nitrogen. That is one of the drawbacks of my research. Though some of the bacteria, like the 4 bacterial isolates, shows the positive for the phosphate utilization, as well as for indole acetic acid test, there is a 2 test, 2 positive tests. For ammonia production, there is 1 positive test. Regarding the enzyme hydrolysis test, all 8 bacterial strains shows the positive towards the cellulose hydrolysis, and in the starch protease phosphate, you can see in the figure also.